open source community building and the essential quality of cat herding. Diane has been designing and implementing products and applications embedded in mission-critical systems at Fortune 500 companies for over 20 years. So, please welcome Diane Mueller.
Over the step. So thank you all for coming in, and I have realized exactly why they positioned this room the way they have. You're all facing me, and I get to look out the window at absolutely awesome view out there. So thank you for your time and attention, and thank you for inviting me. It's a pleasure to be here. I'm going to explain a little bit about myself by decomposing my Twitter handle, which is Python DJ. It's short. I picked it because I'm a developer, a Python developer. I used to do financial applications and all kinds of fun stuff like that. And I used it. I fell in love with a framework called Django, so I picked Python DJ. A lot of my friends are users and non-technical people, so they thought I was doing something with my college background as a DJ, which is what I did, radio announcing and party DJing in college and all of that stuff. I think it really comes down to I'm a snake charmer because I'm a cloud evangelist. And so take everything I say with a block of salt. And really, this is my humble opinion about the face of cloud computing and where it's going these days. So you did mention that I am a community manager for one of the over 100,000 projects that RedHat sponsors and backs and puts engineers on, and people like myself that are cat herders and wrangle people to do open source work. So I'm just working on one piece of it, and I'll explain what OpenShift is in a little bit. Some of you might have heard of it. How many people here have, I know that at least 15 of you went through OpenStack training here. So how many of you are OpenStackers, used OpenStack? So we've got some baseline. I'm not going to go into the technical details of OpenStack, though I did just come back from the OpenStack Summit, so I may give you a few things about this. But what we do with those hundreds of thousands of open source projects is we take them and we back them with enterprise software, and we are slowly and trying to create a complete open source cloud. So everything from the infrastructure layer, which we have right now, we have the most engineers and committers to the OpenStack project at the moment. We also have this open source project called Origin, which is the one that I'm the community manager for, which is a platform as a service. About why that's important. And everything in between is storage. So what we're really trying to do at RedHat is give you everything you need in the open source world to build your own private clouds on top of RHEL, on top of Fedora or CentOS or whatever Linux operating system that you want to use. So we've got a really good handle on that. So what I came here today to talk to you about a little bit was how cloud computing and how it is a means to doing some disruptive transformation in your organizations and in your life, and how it's disrupting the global economy. It's a big title for this, and I gave the presentation title on 2-3 months ago, and I thought, God, even in 3 months, everything has changed again. So I was at last night's lecture, and as soon as I did, and I had to laugh as soon as he started. Mark was saying the thing about nobody should ever say the phrase digital natives, because that's the book that's in my backpack that I was reading one day over here. And this is my 13-year-old daughter, and I have a 17-year-old daughter, and I declare them digital natives, not because they're going to be developers, and not because they're going to code or anything like that, but they have a comfort level from being born in the 2000s and the 1990s with technology and an expectation of technology just being the net that's there. So it's not just the internet, but they just are completely comfortable. And I think he did last night a great job of showing how comfortable people are with creating content and all of that wonderful stuff. So I'm very concerned with not just creating communities of people collaborating on the software, but also the communities of people who are using the software as well. I wanted to talk a little bit about the 5 apps right now that rule her world, and that will change next week. So believe me. One of them is called Wattpad. Anybody use Wattpad? There we go. Wattpad is changing the way ebooks and publishing is done. I thought for a little while that my daughter was not reading enough and not doing enough writing. And then one day I asked what she was doing with her thumbs and fingers on her iPhone, and she was using this app called Wattpad, and she has already published 13 chapbooks online, edited by her compatriots about One Direction and little adventures using an application on her iPhone. She also uses WhatsApp, which is an SMS messaging thing. She has dumped, and so has her older sister, who's 17, they've dumped Facebook. They're off Facebook. They only use Instagram. I had to tell them that Instagram got bought by Facebook, but probably as a defensive move. Polyphore is something, I don't think anyone's heard of Polyphore. You've got Aussie? There we go, all right. So Polyphore, I take as the new Sears catalog. Remember getting the Sears and Roebuck catalog or looking through magazines at wonderful ads and everything where you got to pick out the things you're going to get for Christmas? And Polyphore they've turned the metaphor around where they get kids, and not just kids, but everybody, to create their own ads. Like they pick things from the catalog, they arrange them in a page, and they make these beautiful, sort of like Pinterest, and then they publish them and share them to their friends. And their friends can click on the items in the page and buy them. So it's this whole new metaphor for creating catalogs. And the other thing that we live and die by in my house, and I would love to have a feed line to our house, is Skype, because my 17-year-old's boyfriend lives in Dawson Creek, and they just live on Skype, back and forth all day long. You can always hear somebody talking on the phone somewhere, and they're not talking on the phone, they're talking on Skype into a laptop somewhere in the house. And that's really sort of changed the whole metaphor of our household. So one of the things that I worry about having daughters, and I think we all do, is about 1 in 3 children, by the time they're born, even before they're born, have their sonograms up online. There's an online presence, creating chapbooks, creating Facebook pages, Instagrams, and things. And you try and explain to kids all the rules for using them, and you hope you do a good job. But we really are leaving this digital footprint and trying to explain the rules of the road for creating this content and how that all happens and where it happens and how it leaves a trail that's going to live on forever. Sort of like the tattoo that my friend got, and that is not a rub-on tattoo. He actually got the RedHat Shadow Man tattooed onto his arm. And Adam is one of the DevOps guys behind OpenShift Online, our hosted version of this. So when I really wanted to talk about what's fueling this whole transformation, and I could have picked a bazillion different white papers. I picked the McKinsey report that came out a little while ago about what the disruptive technologies are that are really pushing this. And it really, to me, under the hood of almost all of the technologies that they were talking about, whether it was mobile internet or automation of knowledge work or the Internet of Things or 3D printing, it all comes down to cloud is underneath the hood. So they had a whole long list of disruptive technologies that were there, but I would have that pretty much everything on there at some point touches the cloud, touches the internet, and is being bubbled up and being supported in the transformation of these industries by using cloud technologies. The global impact, but they were saying by 2025, I didn't do the math, 1.7 trillion to 6.2 trillion, that's a big gap. But the potential productivity gains are 20%. It's a huge impact having access to these compute resources and being able to use them to drive not just Polyphore and little ads online, but all of the services, the educational services, the not-for-profit services, and the services that you're doing, to be able to take those and embrace those and push them forward. Because I'm sure all of you have seen the cloud cake and the different layers. There's a new essential basis to this whole thing, the elasticity of this, the ability to do self-service and make things happen very rapidly on there. And we have some new service models that are going out. Service as a software, platform as a service, infrastructure as a service, and I'll talk a little bit then. And lots of different deployment models. I've listened in on some of the sessions here and listened to one of the education folks talking about taking Google and embracing that at Ryerson College. Is Heather still here? But there's just a whole change in the way we're doing business. It's really transforming everything. But I wanted to talk a little bit about disruption in my life. So I'm older than dirt, but not as old as the printing press. But I grew up in the era where the really big thing that they were teaching us at university was, how many of you have read The Mythical Man Month? Yes. So you're in my age bracket. And that was really telling us that adding new human resources to a project doesn't necessarily make it go any faster. That's Brooks' Law. And that's sort of the era that I was going. We still had raised floors, and the computers, the year I was born, and you can extrapolate from this, were really big behemoth machines with energy consumption and cooling issues that were really pretty crazy. When we think about it now, the compute power on that is probably in one machine somewhere, one rack somewhere inside of Rackspace or inside of Rackforce or one of our systems. But the very first, or one of the first jobs that I got out of university was working for a small company called Nike. And I have computer science and math background, and I had, went into this wonderful job because Nike, right? They were making huge investments using aerospace technologies to design sneakers, right? And if you called them sneakers and you worked at Nike, they'd shoot you. So athletic footwear. But this is probably a little dated, probably a couple of years before I got there. But they still had, when I got there, a paper tape machine. And this paper tape machine was driving a metal, on a metal plate, the drill bits and the feed machines to make and that's not me, that's somebody. The early version of November. That's sort of the thing that I was doing. We would drive that, and we were working with the shoe designers to create prototype soles. And the really scary thing about this, I got this picture from the Computer History Museum. I probably worked on that mold, and I probably did the math to create all of the splines and did the graphical plotting of this machine to build this, and I probably broke 2 or 3 drill bits trying to get the speeds and the feeds right to go into the metal to make these molds. And these molds came and they got put on sample shoes. So the stuff that I worked on is now history. The interesting thing about this, for me, was I would make one of these, a size 7.5 if it was a woman's shoe, or a 9 if it was a man's shoe. And then they would take that mold and send it to someplace in China, and somebody would, if it was a successful one, would make all those molds by hand. That was the process then. 25 years later, there's software now, and mind you, Nike put millions of dollars into buying Legato software and all the hardware and the plotters and the machines. That the reason, I think in 1985, they made their first $1 billion. They had a $1 billion year. The following couple of years after that is when I went to work for them. And now everything that they spent so much money on, you can model the entire shoe. And this is software that's, I forget the name of the company, it's generic shoe modeling, has the lathes, all the different soles. And then you can go out and buy a 3D printer and take that model. And see the little USB stick that's on this thing here? It's actually, you take that and upload it, and you could use this and create that prototype, the same thing. I wouldn't have my mold, and I'm sure there's a little bit more going on to do this. But basically, everything changed. All that work, all that hardware, that room full of hardware, that paper tape machine, the math that I had to figure out to do the drill speeds and speeds, everything has changed now in less than 5 years time since the last time I looked at anything outside of Nike. And now I don't even need that machine. I can take that what's on that USB stick, the software that's on the web, upload it, they'll print it for me and ship it to me in a box. So all of that's disruptive technology. If I stayed in that industry, I would have been completely out of a job, having only known that math algorithm. Because what I like to say is that software, the stuff that they were paying me money to do, and the math that I was trying to write algorithms and software to control the feeds and speeds, software is eating the world. This, I don't know if you recognize it, is a picture of an empty Blockbuster, which is down the street from where I live in Vancouver. So Blockbuster got eaten by Netflix, newspaper ads got eaten by Craigslist and a myriad of other things since then. schools, Phoenix and Khan Academy, all this stuff is being enabled by cloud computing. And Borders got eaten by Amazon. If any of you remember 1989 and this movie, in this movie, the interesting thing to me is Tom Hanks played the role of the owner of Fox, the bookstore, which was modeled on Barnes and Noble. He was the predator. And she, Meg Ryan, had a little nice, cute bookstore, and she was the prey. Tomorrow, the predator of Barnes and Nobles, or what's putting Barnes and Nobles into a niche position, is Amazon. And that's all powered by cloud. So tomorrow, and the interesting thing about this is the UK. The UK doesn't give a damn about Thanksgiving, and neither should we in Canada. I'm an American, so I had to call my mother this morning and say, Happy Thanksgiving. But yes, things have changed, and I think what I'm trying to put here is the software is really changing. It's the software that's making the big change here. A while back, Ben hosted a conference, Cloud 2020, at SuperNap in Las Vegas. And we got a tour of one of those huge facilities that is housing these racks and racks and racks. And I had two little epiphanies at this event. The first was there were armed guards through this place. It was so high-tech, it was amazing. And you'd have to be escorted to use the ladies' room with someone with actually an arm to get there. And as we were walking through these corridors, you'd think there would be no humans, but there was actually, every once in a while, you see a sysadmin or a DevOps guy rolling in with his laptop and plugging in and having to do something, having to do some manipulation on that. And I think that was my epiphany, is that there really were humans in those machines. As much as we like to think of the cloud as one having no weight because it's fluffy and white and floats out there in the ether, we all know that there's actually humans behind these things in ops rooms, in cages sometimes, monitoring all of that infrastructure and making all of that work. So it really is a human endeavor. As much as we want to believe that clouds are airy-fairy out there, all of us in this room know that there's a real concrete weight and value to the human and the machine. So, but Moore's law says that we're going to constantly be getting double-fold capabilities built into our hardware and everything. And this gentleman on the top here, he actually broke the news a couple of months ago, Henry Samuel, was predicting in 15 years' time, Moore's law is dead. Because we really, even with the technology and the graphite and all the different ways that we have of making chips and creating stuff, that we'll no longer be able to innovate our way in a hardware way out of this conundrum. And this guy below is Canadian. I think he's at the University of Manitoba, and he just writes awesome books. If you ever get a chance, take a pick up. But he actually calls it Moore's curse, because it gives us the sense that, like with plants or farming or agricultural, that you can't innovate twice as much efficiency by throwing more fertilizer on the field or doing this. There is basically a breakdown in our sense of how much we're going to get. We talk about how many gigabytes of network we're going to pipe into my home or into your university, and we talk about it as if it's never going to break down, it's never going to stop, it's always going to be continually getting better and better. But there are some physical limitations of things that we have to start thinking about bringing software in to gain better efficiencies, because we've gotten used to having, just infinitely increasing power. And so I think what my point is that software is going to start becoming the thing that makes the compute resources elastic, starts getting us real efficiencies out of this hardware, and that's where we're going to start seeing the performance improvements. Because we all expect, and I love movie metaphors, so watch out, they come frequently. We all expect to live in the Terminator world, right? And the Terminator world is, predicated on the fact that we have this unlimited set of resources. But this little guy, anybody recognize this guy with beard? That'll probably look like somebody sitting with us this evening in one of the bars. This is Linus Torvald, the inventor of Linux, who is basically responsible for putting out into the open source world, in 1991, I believe, on Usenet, some of the very, very first versions of Linux, which is basically built, most of 80% of someone gave you that number of the cloud is running on Linux today. So the kernel of Linux comes from an open source one. The efficiencies that we use in cloud computing all come out of this. So I would have to say that one of the big ways that we're going to disrupt in cloud computing is taking it to the next level in terms of open source software. Most of you have heard about OpenStack these days. OpenStack, if you haven't read this book, how many have read Cathedral and Bazaar? This is the book you should ask for your Christmas. I think it came out in 91 or 92, the original edition of it. But it really explains the paradigm of open source. How many of you, a lot of you are in education, how many of you are using Moodle in this conversation? So you're all using open source software. Anybody who's using an iPhone is using open source software. And that's underpinning the technology innovations that we're doing. And of all those of you who are using Moodle, how many of you have made a contribution, I'm not trying to make you feel guilty or anything, back to the Moodle open source code? Yay. Congratulations and thank you. But that's, I think, the real big thing to think about. If you're starting to talk about what the human face and the human side of cloud computing is, there are real people backing these projects. RedHat has a huge amount of engineering force behind working on the OpenStack project, as well as a gazillion other ones there, and that we're really committed to making sure that the communities thrive that are underneath these projects, so that you have the tools to build these clouds and to make pure and wonderful open source projects. So, some of the numbers that are involved in here, just to throw a few out here, is Linux kernel has been around for quite a long time. It's 16.2 million lines of code are involved in the Linux kernel. And OpenStack itself is really very young in comparison. It's 1.84 million, and OpenShift, the project that I work on, is even younger. It's in terms of lines of code and complexity. But it's, the contribution is going on in the community. And these are the developers that are working on the core pieces of your clouds today. And even Amazon has huge amounts of open source code that are underneath Amazon as well. One of the things that I heard a lot of talk about infrastructure and just OpenStack. And I would have that infrastructure is not enough, because there's another kind of humans out there that are working in the cloud and using the cloud and delivering the things that we expect. And for them, and for me as a developer, that's not enough. Because what infrastructure gives you is really all the network and the storage and the compute as on-demand service. So I can get that, I can get my stack of hardware, and basically I have servers in the cloud. But I'm still, as a developer, on the hook for configuring and managing that cloud and the stack that my application needs to run. And let me just tell you, application development got really complicated when we moved to the cloud. It's not that in the old days when I had to do those spline algorithms to figure out the curves on the bottom of shoes. What we're looking at now is if I want my application to scale, I have to do web caching. I need a web server, probably in Apache. I need to be able to install a database, configure that, do all the DNS servers, and hook that up. And then I have to make sure I have all the right hardware, enough networking, do load balancing, and then I have to deal with all of the idiots out there trying to hack my website. And that doesn't even make me scale. That just makes me something that will run on cloud infrastructure. So that doesn't really, as a developer, infrastructure just isn't enough, because I'm still responsible for designing and developing and deploying all of this. So how many developers do we have in the room? A couple of you. So what I'm trying to do is make it easier for you as IT managers and operations folks to help those few people in the room that are developers and to grow more developers. Because there are a lot of unhappy developers out there. This is what happened to me when it got that complicated. I got booted into R&D and management and became a product manager because I did not want to deal with that anymore. I wanted to just code. So it got complicated. I got unhappy. I got promoted and started designing systems. But then along came what I call the modern language wars, and I got a little happier. I no longer had to do a lot of the basics of some of the frameworks are out there around 1995-ish, 91. Some of these interpretive languages that are very, very popular now started to come into being, and the world got better. Frameworks like Django, which is the one that I fell in love with. I fell in love with, a few dozen others along the road. Flask, bottle, they all remind me of drinking because they probably sent me to drinking. But Django was one that really got me back into becoming a developer again, because here it made half of the work, creating the framework and the content management systems. Everything started to get a lot better. But still, the process for me to get my application out there didn't get any better, because I was working inside of Fortune 500 companies, and and everybody knows this thing, like you have an idea, then you go, okay, cool, or your manager would have an idea, which is kind of worse, because it wasn't your idea. Then somebody would get you enough budget to get you the hardware, to submit the request for the hardware. You'd wait till everything got approved, and then you figure out what framework you wanted. You deploy your app server, you'd start testing, you'd start using some tools, and then you repeat, and you configure it for the first, actually, you probably start doing some testing, and then you throw it over to QA. QA would have a slightly different environment than you had on your desktop, and then they'd find a bug, and then you'd have to try and recreate it. And there was this whole cycle of environments in different places where your application was, and you're always trying to fix things that you couldn't because you didn't know what environment your application was being tested on and what the things were. So there was all of this stuff. Not only that, but you push it to production, and then you'd launch it, and then if it was a success, then you'd have to scale it. And you didn't, there was so much, and then you have to wait for more service. So this is really old school. What we wanted, and what we did get, was you'd have an idea, you'd code it, you'd test it, you'd repeat, all in the same environment, you'd launch it, and it would automatically scale. So how many of you have heard of Heroku? Good. So Heroku came along, they did a wonderful thing, Elastic Beanstalk, and a lot of other. They created this environment and the expectation of developers that the LAMP stack and all of the pieces and parts, the version of patch and the applying of patches and the scaling, all of that would be automated. And you could just upload your code. It made programming a lot more fun. It made it a lot easier to iterate and rapidly get your application up in the cloud. It also put developers' expectations of what your IT departments are going to deliver through the roof. Because now they could go with a credit card. First, they could go with a credit card to Amazon and get an instance, and they get their own Linux, whether it was RHEL, Fedora, or Debian, or CentOS. They get their own box in the server. They'd skip you completely. But then they'd have to configure everything. Then Heroku made it even easier because they just give the credit card to Heroku, launch their app, and fail it. And they were, I'll use the phrase shadow IT, it's overused, but they were going around your backs. Because trying to deliver all of that self-service on demand and reduce all that time and that bureaucracy is really now part and parcel of any application developers or web application developers mindset today. Nobody is going to wait for you to iterate and iterate. And the way to get these things done there is to, what I see as the next layer of cloud disruption is platform as a service. And being able to pull that into your IT operations and offer that as your own private platform as a service or as a hosted service at Siberia or on your different cloud hosting providers. And what that does is allows you to go off and take your code straight from Git, push straight in, and all the tools that you expect, whether you're coding in Eclipse or in Jenkins or using any of it. It's not just Python. It's just some of the first early platforms as a service started out as single languages, just Python or just PHP. But pretty quickly, everybody in the pause game really figured out how to deploy multiple languages, multiple frameworks, and add new, what we call at RedHat, cartridges for different languages, so that you could have a plethora or a cornucopia on Thanksgiving of different languages and frameworks and tools to use to deploy your applications. And the really cool thing about this from an IT perspective is it actually puts a lot of compliance and audit capabilities back in the hands of IT, because you control what cartridges or what versions of the languages are available within the platform as a service. You can withdraw them. I wouldn't advise that. Taking away somebody's new JS isn't going to make anyone happy. But you can really keep track of what's being deployed, where it's being deployed, and what scale from a back-end perspective. You can also now apply patches and version control, live and hot patches onto applications and push those things from the platform as a service administrator point of view, or as a developer, you can push those in automatically, and they don't take your application down. So there's a lot of automation that's being added in to the whole LAMP stack deployment capabilities. And that's really, I think, one of the things, the key enablers of the next stage of cloud is bringing this platform as a service and layering that on top of your infrastructure as a service. So it's great that all of you are learning OpenStack and that are starting to deploy OpenStack and pushing that through. That just gives you servers in the cloud, elastic servers in the cloud, and the ability to use them all. But the next layer of disruption comes from the automation of the LAMP stack and the scaling and the ability to put those services at the forefront for your developers within your IT organizations. So I would say that the keys really to cloud disruption is that automation from platform as a service. The other key really here, and you've touched on it in some of your presentations, is availability. And there's two sides to that. There's locality and non-locality. If you don't care where your applications is, you're in probably the best buying situation for cloud. But if you do, if you need a Canadian government cloud that's here and not in the US or something, and you have regulatory things, then you have to start thinking about hosting your own private clouds or creating a locally hosted cloud that's within your jurisdiction. And I think that's been talked to death here. The other thing that I wanted to touch on a little bit is the concept of containers. So when your application is deployed, and how many of you have heard of Docker? So when your application is deployed into a platform as a service, what we're actually doing is creating what's called a Linux container, and your application and your entire stack, everything that's running the Apache web server, the database, and all those pieces, you get your little container is put into the cloud, and we scale that container. We create replications of that. We make that so that you have secure access to that, and no one else. You can't have noisy neighbors, so someone can't come in and hack into your container because it's secure. We secure it at RedHat with something called SE Linux, which is security-enabled Linux, which is a very hardened version of Linux that we wrap around it. So you get containers that are your containers. You can SSH into them. You have root access into them, but you can't get to the containers next to them. So that whole evolution is part of what made platform as a service possible. And now we've come to the next stage, is making those containers portable across platforms as a service, or taking that container, and there's an open source project called Docker out there now that is taking that to the next level and making those containers something that you can take and put on any cloud. So what that means is if I push my application into RedHat's cloud on OpenShift Online, and once we have, the project is still pretty early, but once Docker comes into fruition, we'll make it available on RedHat's cloud shortly. Don't quote me on that, that's coming very shortly. But there we'll be able to take that application from RedHat's cloud, put it on Amazon's cloud, put it on HP's cloud, put it on anybody's cloud, and you can take that application as a whole container and deploy it. So you start to get a level of portability that you've never seen before. So just as the previous session was talking about the internet exchange and aggregating that, think of the power that you have if you can take the best priced cloud, wherever it is, and take your application as a whole. It's not a VM image. That's just the amount of stuff that you need for your application, and move it to any cloud, or spread it out across a hybrid cloud. Put some of it on your private cloud, some of it on your public cloud. So you start to get some real interesting portability capabilities with the new containers that are coming in. The price wars are really, I love it every time we have Amazon reInvent happens, because there's always a price reduction thing that happens, and Red Hat's cloud actually right now, OpenShift, and is running on Amazon, and so we've got lots of experience running there, as well as on OpenStack for lots of our customers. But when they announced their price cuts for at Amazon, I think we knew about it the day before. I think right at the same time, we got to cut our prices in half. right? So we get to take advantage of all those price cuts, and it's really becoming, in the public cloud space, a very commoditized world. And with the application portability from containers and some of the new features that are coming in, you're really going to see a lot of those prices come down even more, and the public cloud become even more portable and more containerized. So high availability is becoming more readily available. It's not totally readily available yet. There's certain aspects of it. So some of the work that I did in the early days of my career was around Python and financial applications and doing some huge number crunching to do those lines and the math that went into them to figure out that. It was some huge number crunching. Took lots of compute resources. And the high availability, even Microsoft Azure is making itself now available in high availability compute centers. So there's lots of that starting to come online, so we're starting to get that. There's a huge amount of efficiency and scalability gains that are coming down the pike. What we've done in OpenShift is enabled something called application idling. So when your application isn't being hit by the web server, there's no traffic coming in, it goes down to idle mode, and you're not being charged for that time that you're used there. So you get an efficiency there. We've also added in the ability to scale your not just your compute resources, but your application up and down based on business rules. So there's a slightly different, when you think about compute resources for platform as a service, you're usually thinking about how many instances does my platform as a service as an aggregation have. So I spun it out on 15 or 2,000 servers, but my application, not always, with every platform as a service, you get the ability to do the same sort of up and down scaling. You kind of set an upper limit, you roll up there, but you have to manually roll that down. There's new technology advances that are coming, and that we've enabled inside of OpenShift to let you scale up and scale down. And the really cool thing about this is we learn all of this stuff from collaborating with our customers, with other people who are contributing to the community, and adding even the most basic bug fixes that come in from OpenShift Online, the hosted version, add to the community and the contribution for this project that I get to work on. And it's a hugely iterative process. OpenShift itself, every 3 months, we do a new release of OpenShift Origin, the core. We have another release of the enterprise version. And actually, about every, probably, I would say, 4 to 6 months, the enterprise version gets iterated too. There's lots of change going on, and we're trying really to keep up with all the different projects. We work very closely and do a lot of cross-community collaboration with the OpenStack world. We've done, if you're using OpenStack, you'll have learned probably a little bit about in the new release of Havana on OpenStack. There's a project called Heat, which is basically OpenStack's version of Amazon's Cloud Formations, which is an orchestration set of tools. And we've taken that and created some default templates for deploying with Heat on OpenShift for both deploying and auto-scaling. So when you install the latest version of RedHat's OpenStack, the RDO, the open source one, not the enterprise one, if you just download the open source one, you will get the Heat templates and be able to automatically just install OpenShift and have a platform as a service. And that's sort of our goal, is to cross-community collaborate and make sure that we have one cohesive open source cloud offering that we can use to build private clouds. Whether you're using Fedora, or you're using RHEL, or you're using CentOS, or you're building it on bare metal, we try and make sure that OpenShift, the project that I'm working on, runs on CloudStack, which is another competitor open source project to OpenStack, on AWS, on bare metal, and everything we can possibly throw at it to make sure it works on any cloud. But we really have been focusing at RedHat very closely on making sure that it's optimized to run on OpenStack. And within the OpenStack world, there's tons of projects, Nova Compute, Neutron for networking, lots and lots of different projects that we've got our fingers in, and we're trying to make sure that we contribute in a good way as a good community member. There's a new initiative out, which I think is a bit of a game changer. It's called Solemn, and it is taking that whole concept of platform as a service and flipping it around the application lifecycle management and building an API into OpenStack for basically a lot of the functionality that platform as a service does, but making a common API. So what becomes, from my point of view as a platform as a service vendor or project leader, it's a great thing because the value add that we have is our knowledge from running the platform as a service, the containerization and the different pieces that we bring to the party that make that whole automation layer work and sing and the business rules behind it. The guts of making it run and scale on and access all of the resources on OpenStack, there ought to be an API for that. And that's another project that we're deeply involved in as well. So there's some real disruptive things happening out there in the world, but they're all backed by humans, and they're all done with a real, from my point of view, I do them not just in the name of the users, but in the name of the developers, trying to enable developers to be able to build and create without all the headaches of maintaining and scaling all the lab stack to make that happen. So really, my goal is to make sure that we empower the developers to test, launch, and especially to fail as quickly and rapidly as possible, to relaunch, and to make those applications scale. And the more we do as a community and as IT providers and organizations delivering that to make sure that they have the services and the tools to do that, the better off the innovation and the bigger the bang for the buck is going to be in the disruption that cloud allowed you to create and the transformation in your organization. So part of my conclusions really were around is that my sense is that the digital natives are restless. So they'll be on, like my daughter will be on beyond Polyvore, beyond Instagram in like next week. There'll be something else. They have a huge appetite for new applications, new things, some new features, some new meme generator, new goat. That there really are humans in the machine. We shouldn't forget that. That there are some real human limitations to servicing and the DevOps and the operations and the systems behind these clouds. And we need to make sure that the tools are there for them to monitor and manage them. And we're working. Humans don't scale, just like you can't feed that goat twice as much and expect to get twice as big of a goat without killing it. You can't innovate a goat that way. And the machines will not scale continuously. They're not going to, the chips are not going to continuously improve. The network cables are not going to continuously improve without software helping to gain efficiencies. So we have to start looking to software to do that. And that really, my core message to you is that software is a collaborative endeavor. There's lots of places where you touch on and you use, from Moodle to your iPhone to your Android to OpenStack, where you can touch, and even if the only thing you do is file a bug, you don't have to fix the bug, file a bug, give feedback on the user experience, talk to the community members, go on IRC and chat with someone and tell them when you have a problem. Sharing that little morsel of information could be the spark that changes and helps someone innovate one of the many, many projects out there and helps people get that done. There are humans out there working really hard and collaborating together to build this common platform. And I really believe that the open source collaboration that's going on is really what's going to drive the next generation of disruption. And even the model of open source collaboration is changing as we speak. In the past, where someone would, and RedHat is just as guilty of it as anyone else, someone would build a project in-house and throw it over the fence and say, here's my beautiful blah, come work on it with me and try and build a community around it. Now what we're starting to see with some of the projects that I'm working on is people have an idea, a design concept, and instead of throwing out code, the first thing they'll do is they'll come together as a community and start looking at the use cases and building. And so what we're seeing now is more and more open source design. So even earlier on in the process, communities are being built around needs and assessment and use cases and looking for user requirements. We're seeing a little bit less, and I think that's the disruption even in the open source world, because it's really uncomfortable for a lot of people not to be able to go to GitHub and download a chunk of code and start testing it. That's a really uncomfortable thing if you're a developer. If someone just throws out a concept and says, come work with me on this. And we're starting to see a lot of that change and a lot of that kind of collaboration on design and innovation, because it's not worthwhile just to throw that code over anymore and have people start hacking on it. You really need to get people in earlier. So my goal is really to keep not just the developers, I have the 13 and the 17-year-old, just to keep the digital natives happy, to keep them, to educate them, to keep them informed, to get them the skills, not just to create memes or little graphics or pages, but to get them to use those skills that they're learning to get jobs in graphic design or get jobs working at magazines or doing the next thing, whatever it is. But I want to keep those digital natives happy and create a better world for the kids as they grow up and the education tools they have. And I think the way to do it is really to collaborate and take advantage of all this transformation that's happening. And then at the end of the rainbow, there will be a pot of gold for all of the developers creating the apps and all of you. And it will be a wonderful world. So I believe that cloud transformation is really what's going to power the next series of innovations in all of your organizations and for the digital natives that I'm raising. Thank you.